Hello, we are Team Galacticos and we're going to present the evidence to argumentative examination of the challenge of the design and development of robots.
The way we work as a team was by listening all the tasks to build the robot. Then we gave each task to a team member who understood the topic very well, like control, dynamics, or kinematics. Once the task was finished, the rest of the team reviewed it carefully to see if there were any questions or ways to improve it. The method we used was to research the main topics about the robot, like the motors or how to control it. The team shared their ideas and, if needed, vote for the best one. That idea was tested by physical or simulated prototype. If it worked well, we accept it. If not, we start the process again.
Well, now for the kinematic model of the robot, we obtain first the homogeneous transformation matrices in order to obtain the position and orientation of the n effector. Once we obtain that, we solve the IgM using the pulse method. We watched that our equations for the position of the n effector were of a type 8, and we also solved it using plain trigonometry.
For the automatic control system, we made this PID controller in Simulink that adjusts the PWM duty cycle of the motors based on angular error.
With the compliance with the three models were successful integration of an IgM, we were able to define the Euler-Lagrange formulation and programmed a PID controller for the robotic arm, and we were able to define the torque of the motor.
Here is a demonstration video of the robot arm with all the equations and all the evaluations applied in the control and programming of the robot. Here is a demonstration video of the robot arm with all the
These are our results of two different traces. The first configuration shows 5 different points along the same line with a separation of 3.5 centimeters, and the second configuration shows a small square of 3 by 5 centimeters that shows the robot's dependence on its momentum.
In these three plots, we can see the angular tracking error, the joint angular position versus reference, and the control signal of the two motors of a robotic arm. So for my individual contribution, I did the robot design and manufacture, where the design was focused on reducing the load of the motors by using gear trains, and the material, which was laser cut MDF, was chosen for its durability and manufacture speed. The robot circuit was very simple. It consisted of a power source, a motor driver, an ESP, two motors, and four unit switches. And I also did the final robot control, which was a simple PID controller that used angular error in order to estimate a PWM response.
My individual contribution was to find the inverse geometric model of the robot with the pulse method, to find the Jacobian matrix and the singularity configurations of the robot, and also the development of the Euler-Lagrange model.
Now, my individual contributions for this project were first for the DGM was to obtain the homogeneous transformation matrix in order to obtain the position and orientation of the effector, and on the model of dynamics, my contribution was to obtain in a symbolical way the adverse iteration for the Newton-Euler formulation.
My contribution was to set up the different positions of the robot and define the variables and equations needed to the Newton formulation. Then I test everything in MATLAB to see the results were correct or incorrect.
My individual contribution to this project was in the IGM that obtained the numerical solution and validation of the results, and also in the Newton Euler in the dynamics part, doing the code for the outward and inward iteration and evaluation of the symbolical equations.